Okay, so we'll be doing some exam practice questions. They won't be in any particular order, but you need to be able to do all of these questions. And if you can do them confidently, you should be fine for your exam. Okay, our first question, we need to subtract 99 from 6,021. So first we set up our algorithm, and we need to make sure everything is in the correct place value. So don't squish up your numbers. And we always make sure we have the bigger number first on top when we're subtracting by hand. And we're going to be to take away, and we've got 99, so 9 is in the ones column, and the other 9 in the tens column, straight under the 2. Okay, and now, can we go 1, take away 9? No, we don't have enough on top to subtract. So this is where we need to borrow. So just change my colour. And I can borrow a 1 from the 2. So 2 now becomes 1, and now this becomes 11. So 11 take away 9, I'm left with 2. Now, I forgot a 1 here, and I have to go 1, take away 9. Can I go 1, take away 9? No, because I don't have enough on top. So this is where I have to now borrow. But the problem is we have a 0 here, and I can't borrow anything from 0 because there's nothing there. So I'll move across to the 6. So I will borrow a 1 from the 6, and that becomes a 5. Now, I can't just put my 1 here. I can't skip that 0. The one I've borrowed has to always go on to the next number. So if I go on to the next number, on my 0, I end up with 10. But I haven't finished my journey. I have to now borrow a 1 from the 10 and carry on to that 1 here. So I'll just change my colour. So I borrow a 1 from the 10, and 10 take away 1 is 9. And then I put that 1 next to this one here to give me 11. And 11 take away 9, again it is 2. And now 9 take away, there's nothing there. Imagine there were just zeros there. 9 take away 0 is just 9. And 5 take away 0 is 5. And there's our answer. I could put a comma, so 1, 2, 3, and put a comma. And we have 5,922. Now this question here, I can see I have decimals, and just check our operations, we are adding everything. And if we add everything, we can just do it all at once. So this is where you really have to be careful with your place values. And I'll start off with 10.85. You don't have to, with addition, you don't have to have the bigger number on top. Just make sure your decimals are in the correct place value. And 85. So first write your first number, and now every other number, you have to make sure the decimal is the first thing you put on. So 231.1, there's my decimal. Okay, that's my first thing that I'll be doing. And now, what do I have after my decimal? I've got a 1, that's in the tenths column, and I can see my 8 is after that decimal, that's also in the tenths column, so that 1 goes straight under the 8. On the other side, I have another 1, which is in my ones column. So if I have a look here, on this side, I've got a 0 there, and my 1 will go under that 0. They're both in the ones column. And then after my 1, I have a 3, which is in the tens column, and there's a 1 in the tens column. And then 2 in the hundreds column. So 2 is just out here on its own. There's nothing above it. Okay, and then of course we have plus 5. Now be very careful. So many students will get this plus 5 and just put it over there and then calculate their answer. It's a big mistake, because where is the decimal that's invisible? We know there's an invisible decimal right there. And if I put my 5 here, well, the decimal's there and it should be aligned with these decimals. So please be very careful. So my decimal is the first thing I put, and then I have my 5 on this side, on the left side, so it's under the 1 and 0. And I can see that everything is in the correct place value. If you wanted to, if you are a messy writer, you can draw some columns, if that helps, to make sure you put the numbers in their right columns. Okay, if that helps you, you can do that. Now it just looks all messy, but you can see what I mean. Okay, and it's easier to do that on paper. So now 5 plus, if you wanted to, in the empty spaces, you could put zeros. Okay, if that helps you, you don't have to, because if you have nothing there, you know you have 0. So 5 plus 0, 0 is just 5. Oh, sorry, before I do that, what must I put first? I must put my decimal. And now 5 plus 0, 0 is 5. 8 plus 1 is 9, plus 0 is just 9. 1 plus 5 is 6. 1 plus 3, there's nothing there, is 4. And 2, there's nothing to add with 2, so it stays in the hundreds column. Okay, so I can see I ended up with 246.95. So with these questions, just remember you have to align the decimals first, and then you place your numbers accordingly. Our next question, we are dividing. We have 2,892 divided by 2. So now when you see division, it's a long sort of number, you have to get your, what I call a bridge ready, or your algorithm ready for division. And if you're not sure which goes where, remember this division also, we're also saying we can write it this way, 2,892, and I know that division can be written as that vinculum, that line there, our fraction line, divided by 2. Okay, just do that in case you forget, where does my 2 go? Does it go out here or in here? And then this top number will fall down and go under the bridge. So this number here will be under this bridge. Just a way you can remember this. And the 2 is then on the outside. Now we don't start calculating, okay, because we now know we no longer write remainder 5. If we have remainders at the end, we turn those remainders into decimals. This one may not have any decimals, but to get into the good habit, we'll put our decimal here. I know my decimal is invisible and it's right here for this number. Sorry. And I must put a decimal on top there. Now, why does it keep doing that? All right. And I can just extend my line a little bit. I should have made it a bit longer. And on the other side, after this decimal, add some zeros to start you off. And like I said, we may not need it for this question, but other questions we will. So now we just divide. 2, we can say 2 into 2. It can fit once. I won't say 2 divided by 8 because that's actually wrong. I really have 8 divided by 2. So I'll be saying 2 into 8 can go, well, 2 times 4 is 8, so 4 times. There's no remainders. 2 into 9, well, 2, 4, 6, 8, that's 4 as well. But I haven't reached 9 yet. I'm at 8, so there is 1 remainder. And now that is a 12. So 2 into 12 can go 2 times 6, so it's 6 times. And I stop. I had no remainders. If I had a remainder, I would have had to have carried it onto this 0 here. So my final answer, I can write it down here, is 1,446. And if you wanted to, you can go 1, 2, 3 and place a comma. And we're done. Okay, so this question we have 4 divided by 5, and a trick is, see how my number at the beginning is smaller than this number? I know straight away I will be having 0 point something. Now, in case you get confused, I'll write it in fraction form, 4 divided by 5, and I know the 4 will fall down and go under the bridge. So there's my 4, and my 5 is outside. Now we don't start, we now have to put our decimal. Our invisible decimal is here next to the 4. We don't have to worry about the decimal on the 5, just in here. And that decimal goes straight on top. And now we add some zeros just to start us off. Put at least 2 or 3 zeros and to start you off. So 5 into 4, can it go? No, we don't have enough. So we have a 0, put a 0. And I'll just change the color. So the 0 there. But we didn't use this 4, so that 4 is a leftover or remainder. So that 4, we have to now put it next to the 0. And you can see now we are past the decimal point. So we're now, our next number will go in the 10th column. Now I have 40, which is 40. So 5 into 40 can go, 8 times 5 is 40. So 8 times. There were no remainders, so that's my answer, 0.8. If I kept having remainders, I'd keep adding it on to the zeros until it stops or until you find the pattern. So the next one we'll be doing, we have to find the pattern. Okay, so this one, 5 divided by 6, same as writing it as 5 divided by 6. And I know I'm going to have 0 point something. So get my division symbol ready, the bridge, and 5 falls down under the bridge. So I have 5 down there, and my 6 is out there. Decimal point, the next thing I put, in case I have remainders. And I will be adding some zeros to start me off. Okay, and now 6 into 5, can it fit? No, so we have 0 on top. We haven't used a 5, so we will carry that 5 onto the next number, which is my 0. That's why it's important to set your zeros up. Now I have 50 over here, And 6 into 50, well, I know that, let's see, 6 times 6 is 36. No, I can go a bit higher. And maybe 6 times 8, what's that? It's 48. Perfect. So I now have 6 into 50 goes 8 times 48, so I have remainder 2. Keep going until you see a pattern or it stops. Now 6 into 20, that's 3. Well, 3 times 6 is 18, so I'll put a 3. 18, 19, 20. That's 2 remainder. Oh, I've got 20 again. Let's see what happens. 6 into 20 can go, well, 3 times again, and I still have a remainder 2. I'll add another 0. So what do you notice is happening? 6 into 20, again, it goes 3 times, remainder 2. So you notice that this will never actually stop. I will have 0.833333333 all the way until infinity and beyond that. So there's no need to write anymore because I have found my pattern, and my pattern is 3, 3, 3. So, and it continues. So my final answer will be, it equals to 0. Now 8 isn't in the pattern, so I write my 8, but the number in my pattern, there is only one number, and it is a 3. And because there is one number, that's where we put a dot on the top. And that dot is saying that 3 actually goes on forever and ever and ever and ever. It's just that we can't be bothered writing it forever and ever and ever. So that dot sums it up for us. So that is our final answer. On your calculators, I'll just bring my calculator up. If I push 5 divided by 6, let's double check our answer. Divided by 6. Yep, it shows me I've got 0.833333. Now, some calculators, not with these kind of numbers, but some calculators might round off the last number. Okay, so just say we had 77777, you might have an 8 at the end because your calculator has rounded it off. Okay, just keep that in mind. Our next problem is on multiplication, and we can see we have down here 421. So I'm in my hundreds column. Now when multiplying, it's good to always put your bigger number on top and then your small number on the bottom, and always align them up in their place values so you don't get confused. Now in our ones column we have a 1, so we always start from this number here, and let's go. 1 times 2 is 2. 1 times 1 is 1. 1 times 1 is 1. 1 times 2 is 2, and 1 times 3 is 3. I didn't have to do any carrying because some questions you actually have to carry, so just keep that in mind. 2 next, and now 2 is in my tens column. Now if I just start going 2 times 2 is 4 and I write 4 here, my 4 will be in the ones column. That's why now as soon as you finish your ones and you're in your next column, which is a tens column, how many zeros in 10? Well, there is 1 0, which is why we add that magic 0, because now that 2, that's not really 2, that's actually 20 because it's in my tens column. And what's 20 times 2? 20 times 2 is 40. But because I put my 0 there, it's reminded me of that. So now what is 2 times 2? 2 times 2 is 4. And have a look. Because I put my 0 there first, I actually can see I have 40. And now I can keep on going. 2 times 1 is 2. 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. Make sure everything's aligned in the correct place value, and draw columns if it helps you be neater. Now have a look at this one. This 4 is in the hundreds column. How many zeros in 100? 2 zeros. So this is why I must put my 2 magic zeros now, because that is actually 400 times 2. Now because I have my zeros ready, well, what is 4 times 2? 4 times 2 is 8, and you can see we have 800. By putting those magic zeros there. And let's continue now. 4 times 1 is 4. 4 times 1 is 4. 4 times 2 is 8. And 4 times 3 is 12. And I put my 1 there and my 2. If I had another number here, I'd have to carry, but I don't. And now I can see everything is in its correct place value. And let's do this. So we've got 2 plus 0 is just 2. So now we have to add all of these numbers together, and 1 plus 4 is just 5. Now 8 plus 2 plus 1, 8 plus 2 is 10. 10 plus 1 is 11. Put the 1 down and carry the 1. 4 plus 2 is 6, plus 2 is 8, plus 1 is 9. So remember, that is not a 12. When we're adding, that's an extra 1 we're adding. Subtraction, if we were subtracting, that would be a 12. Just keep that in mind. 4 plus 4 is 8. 8 plus 3 is 11. Put the 1 down, carry the 1. I'll do a smaller one to say it's not 16, it's just 6 plus 1 is 7, and 7 plus 8 is 15. Carry the 1. 2 plus 1 is 3, and 1 plus nothing is just 1. And there is my answer. Now I'll put some columns in, some commas in, so I can read my number. So always start from this end, and count every 3 numbers and put a comma. 1, 2, 3, comma, 1, 2, 3, comma. And I can see I've got 13,519,152. Okay, this question here covers some keywords, and we can see A, we've got prime numbers, B, we have the keyword factors, and C, multiples. So with A, prime numbers, we know prime numbers are numbers that have only 2 factors, 1 and itself. No other number can go into that number. Okay, so if I have a look at these numbers up here, okay, so what are the prime numbers? And I'm given these numbers here. So out of these numbers, what are the prime numbers? So let's have a look. Is 1 a prime number? It actually isn't. 1 isn't a prime number. And just remember, prime numbers are numbers where we have they're divisible by 1 and itself. So 1 can be divided into this number and the number itself. So if I have my 1, I'll just draw it here. I know that 1 can be divided into 1, but can anything else be divided into 1? No, I only have 1 number. So 1 is not a prime number, okay? Because only 1 can be divided into it. Now with my 2, let's have a look. If I've got 2, what can be divided into 2? I know 1 can be divided into 2 and 2 can be divided into 2. Is there anything else? No, so 2 is a prime number. 1 can be divided into 2 and itself the same number. I'll try 3. So 3, once again, 1, and we know any number can fit into a whole number, and itself. Do I have any more numbers that can be divided into 3? No. So 3 is also a prime number. Let's try 4. All right, so I've got my 4. Now here, yes, I know 1 can be divided into 4. So 4, we know 1 can go into 4 and 4 can go into 4. But this 4 also has, if I was drawing a factor tree, well, I know that 2 times 2 can give me 4, okay? So because it now has another factor of 2, because I can go 2 divided into 4, 4 is not a prime number. And the same with 8, 1 and 8 can be divided into 8, but 4 can be also, and 2, so they're factors of 8. 9, is 9 a prime number? It looks like 1 because it's an odd number, but actually I know that 3 can be divided into 9. So 3 is not a prime number. And 10, well, I've got 1, 10, but I've also got, I know 2 times 5 gives me 10. So 2 and 5 are factors of 10. So 10 is not a prime number. So the only prime numbers in these given numbers were 2 and 3. And keep in mind, 2 is the only even number that is a prime number. Every other even number is not a prime number. And what do we call, what's the opposite of prime numbers? We call them, it starts with C, composite numbers. So 1 and 2 are prime, 2 and 3 are prime numbers, okay? And every other number, 4, 8, 9, and 10, we call them composite numbers. Not the 1, but 4, 8, 9, and 10. Next one, factors of 8. So we know factors, the keyword factors means what numbers can be divided into this number. And factors always have a partner, and you'll see what I mean. So I know, for example, a factor of 8 is 2, because I can go 8 divided by 2 to give me 4. So the partner of 2 is 4, because I know that 2 times 4 will give me 8. So 2 and 4 are both factors. Do I have 2 and 4 up here? Yes, I do. So to write the factors of a number, you have to write them in ascending order from smallest to largest. And of course, every number has a factor of 1, including 1, and itself. Okay, so first of all, I can write, so my answer, I will write my 1 first. I'll leave some space and I'll have 8 on the other end. 8 is my largest factor of 8. It can't go any higher. And in between, I know I can put a 2 and a 4. Is 3 a factor of 8? Can I go 8 divided by 3? No, and I can't go 8 divided by 9. 9 is too big. So I have put a comma. The next number will be 2. The next number will be 4. And there we go. 1, 2, 4, and 8 are all factors of 8 because they can be divided into 8. And we write this in ascending order. Now, multiples is a bit different to factors, and it is more trickier to understand. That's why you think of that game, Snail Trail. If I asked you to count or say the multiples of 2, you would go 2, 4, 6, 8, 10, 12. And multiples, the key word in multiples you can see is multiply. So what if we multiply 2 by a number, just say 2 times 1, 2 times 1, the product or the answer is 2. So 2 is a multiple of 2. Next number, I would have 2 times 2, which is 4. So 4 is a multiple of 2. Okay, and you keep on going. 2 times 3, I know is 6. 6 is a multiple of 2. And 2 times 4 is 8. 8 is a multiple of 2. And I'll do one more. 2 times 5 is 10. So 10 is a multiple of 2. So 2, 4, 6, 8, 10, they're all multiples of 2. I'll stop there because I can see my highest number here is 10. So now I'm going to circle the numbers that I have up here, and I can see down here. I've got a 2 there, so 2 will be in my answer. 4 there, so 4 will be in my answer. Do I have a 6 here? No, so I won't circle 6. I have an 8, so 8 will be in my answer. And I have a 10, so 10 will be in my answer. Okay, and once again, to write your final answer, I'll just make some space here. Okay, our final answer, we write it in ascending order. So multiples of 2, they are 2, my smallest number, 4, 6 is a multiple of 2, but I'm not writing it because I don't have a 6 up here. So out of these numbers, there's 2, 4, 8, and 10. And they are the multiples of 2 out of these numbers. Okay? Now, I've totally lost count of my numbers, so I just thought I'll use a 9. So sorry about that. Now, our next thing is, let's look at this symbol here, which we call the radical sign. Okay? Now, this one here, I'll draw another example of the radical sign. I could have a 3 out there, and you can have any number you want as a power. That 3 is not a big 3, it's a small 3, a power 3. Now, with the radical sign, you have to remember that this one here, where you see no number, it's actually called the square root. This one's called the square root, and we know that any small 2 in maths, we call a square. For example, if I have 2 to the power of 2, I can say 2 squared. But where is the invisible 2? The invisible 2 is sitting over here. We don't write it in maths, but there's actually a 2 sitting there, which is why we call this radical sign the square root. Okay? This one here isn't the square root because I have a 3 here. So you could say 3 root, or you can actually say cube root. Now, with this square root, if I put a number in here, the square root of 4, okay, I'll write it again down here. So that's the question and how it would look like. There's no 2 visible. And what it's asking you is, remember, is there a number times itself 2 times to give you 4? And to show some working out well, and when you do this, always start with the smallest numbers. I know that 2 times 2 is 4, and it has to be the same number multiplied with itself, and this tells me 2 times to give me 4. And look, there is a number. So the square root of 4 is 2. Okay? So let's try the cube root. Let's see, if I put an 8 in there, okay, is there a number times itself 3 times? That's what it's telling you. Remember, this symbol here and this number, they are asking you a question. So if you want, write the question down if you've forgotten this. Is there a number times itself 3 times to give you 8? Always start with 2 and make your way up. So a number times itself 3 times, so 1, 2, 3. It has to be the same number. That's why we say itself. And let's see what this gives me. 2 times 2 is 4. 4 times 2 is 8. I got 8. So the number is 2. So the cube root of 8 is 2. And I also want you to make sure you can put this on your calculator. So just try it now and see if you can do this and get a 2. We'll do one more. What about the cube root of 27? So once again, we always start with 2. Because we have 2 times 2 times 2 up here, and we got an 8, I know it can't be 2. This one can't be 2. I have to try and get 27. My next number to use would be 3 times 3 times 3. And let's see what I get. 3 times 3 is 9, and 9 times 3 is, it is 27. So the number times itself 3 times to give me 27 is actually 3. So the cube root of 27 equals 3. And here's some working out to prove it. Now sometimes, if I had the square root of 8, is there a number times itself twice to give us 8? So the square root of 8, we know there's a 2 there. Let's see, 2 times 2 is 4. No. 3 times 3 is 9. No, and I've passed 8. So sometimes there is no number to give you a number under the radical sign. And in that case, that's all we have to use our calculator. And if you push the square root of 8 on your calculator, you'll see a long decimal that has no pattern. And it's a number similar to pi. Okay, so keep that in mind. Now this question here, it's asking us to simplify, and we have 2 times 3 times 2 times 5 times 3 times 3. It's not asking us to calculate. If it's a calculate, then you can just go 2 times 3 is 6, and 6 times 2 is 12, and so on. But simplify means, the question would also say using index notation. So we have to change our powers. So what you do is, okay, there's multiplication in between everything, so we can do this. First write your first number, and we see we have a 2. Now all you're going to do is, how many other 2's do you see? We've got 1 here and 2 there. So altogether we have 2 2's, so my power would be 2. And that's it. Then write your times. Your next number or base is 3. Do you see any more? So how many 3's in the whole thing? 1, 2, and 3. So I would have 3 to the power of 3. And of course, times goes in between every number. That's our operation. Do not put plus. And we have a 5. Do you see any other 5's in the whole thing? No. So the 5 just stays there. And there is actually an invisible 1 there, saying there is 1 5. And that will be your final answer. We have simplified this. And just to double check if we're doing the right thing, if I have 2 times 2, I know 2 times 2 is 4. And what is 2 squared telling me? 2 squared is telling me 2 times 2. So remember how to use powers. If I had, for example, 3 over here to the power of 3, that is telling me 3 times 3 times 3, which is 27. And we can see that we have 3 times 3 times 3. So it's actually the same thing. This and this will give you the same answer. You can try it on your calculator. This is just in simplified form. Okay, so this question here, I've decided not to write numbers anymore, so you can write your own numbers. We now have, it's starting to get sort of long, and we can see we have multiplication, subtraction, and division. We have no negative numbers, but this we have to use, and remember your BIDMAS. So if it helps, write it down. And of course, we know we do 2 arrows saying division and multiplication are equal operations, as well as addition and subtraction. So with this question, what do I do first? Do I have brackets? No. Do I have an I for index numbers? Do I have any powers? No. D for division. Do I have division? Yes, I do. And I also have multiplication over here. So these 2 operations are equal, but they're away from each other. And they're separated by subtraction. But subtraction is one of the last things that I do. Addition and subtraction come last. So I'm not going to go 5 take away 8 first. I have to, now, as part of your working out, you can put brackets in saying, I've got to do 2 times 5 first, and then I've got to do 8 divided by 2 first. So you put in your own brackets to remind yourself you must do times and then division first. 2 times 5 is 10, and 8 divided by 2 is 4. Now stop there. We'll show some working out. So I now have 10. What's in between these 2 brackets? Take away 4. And then what is 10 take away 4? 10 take away 4 is 6. And there we go. Okay, this one here, once again, we're using BIDMAS to work this out. And this time I see I have brackets, so I'll be working inside the brackets first. I also have an index number, 2 to the power of 2. So don't go 2 times 3 to give you 6. We first have to change this 2 squared, or 2 to the power of 2, into its number. And I know that 2 to the power of 2 is really telling me it's 4. Okay, so that number was actually 4. Now, I'll work in the brackets. Now, please be careful. If you went 2 plus 5 to give you 7, and then 7 times 2 to give you 14, if you had 14 here, you made a big mistake. In the brackets, what do we have? We have addition and multiplication. What comes first out of these two? Have a look. Multiplication comes first, then addition. So I will go 5 times 2 first, okay, which gives me 10. And then what is 2 plus 10? 2 plus 10 is 12. So inside these brackets, you should have had a 12. I will stop there and start my working out. So I have 4 times 3 plus 12. Check your operations, multiplication and addition. I know multiplication comes first. It's above addition. So 4 times 3 is 12. I've got plus 12. And last of all, what is 12 plus 12? That is 24. So your answer should have been 24. Our next question. Once again, we're using BIDMAS. Now, if you notice with this question, we have 2 different types of brackets. These brackets here that look like a part of a rectangle, and then these brackets inside. And the reason why we have to have 2 brackets is we have to work inside out. So don't do these outside brackets first. We work inside out. So inside these big brackets, we have these brackets. And in these brackets, we have 8 plus 2, and 8 plus 2 is 10. Now, these brackets are gone, and we are left with these big brackets here. So I'm going to show that by writing it out again, so it's nice and clear. We haven't gotten rid of all our brackets. We have these ones here. They're a funny shape, but they are still brackets. Divided by 10 plus 10. And now I must do what's in the brackets first. 20 divided by 10, I know is 2. And then to show clear working out, you must have 1 equal sign per line and show your working out step by step. Okay? Now these brackets are gone and we're left with a 2. So those brackets are gone. And that's why we have a 2 here, plus 10. And now we work from left to right. 10 plus 2 is 12. And then I have plus 10. And 12 plus 10 is 22. And that should have been your final answer. Okay, so try the next few questions before I do them. And this involves our skills in negative numbers. So there's 4 different questions that should give you enough practice. Now, whenever you see 2 negatives sitting together, we know 2 negatives make a positive. So I'll be left with minus 2 plus 3. And minus 2 plus 3, if you get stuck, draw a number line if it helps you. But because one's a negative and one's a positive, the difference between 3 and 2 is just 1, because 3 take away 2 is 1. So I know my answer will be 1. But would it be a positive 1 or a negative 1? It will be a positive 1 because 3 is larger and 3 is negative. And we know we always go to the left of a number to see if it's positive or negative. And like I said, just use a number line if you can't do it mentally. Number 2, what's our operation? We are multiplying. And we know when we multiply negative numbers, or positive, the signs come together. So because I have multiplication, I am saying minus 1 times a minus 2, or negative 1 times negative 2. We are not saying times and subtract. That's why some questions, they put brackets around the negative numbers to say that we're multiplying a negative 2. And the brackets don't have to be there because inside the brackets, there's nothing for us to calculate. So we've got a negative, and we know that rule or that trick. 2 negatives that come together will make a positive. Or if it's an even amount, we will have a positive. And 1 times 2 is just 2. And that's your answer. And we know the positive can be invisible because if I have a 3, I know it's a positive 3 without having to write the positive. But you can if you want to. Down here, number 3, 4 divided by 2. Well, I know I have a positive here because there's no negative. And 4 divided by 2, I know is 2. A positive and a negative, they will come together to make a negative. So my answer will be a negative 2. And another way is if I have 1 negative and I'm dividing or multiplying, because it's odd, my answer will be negative. So using that trick, number 4, check your operations. We have multiplication everywhere. There is no times. There is no addition or subtraction in between the numbers. They're all being multiplied. And I can see that I have really 1 times 1 times 1 times 1 times 1. So I will have an answer that is 1. But is it going to be negative or positive? And you can go a negative and times a negative makes a positive, and a positive times a negative makes a negative. Or you can do that trick. Count how many negatives do you see? 1, 2, and 3. And because it's an odd amount, 3 negatives will, because it's odd, make a negative. So remember, odd numbers, odd negatives will be negative. If they're even negatives, they will be positive. What we'll be doing is a worded problem involving negative numbers, and this was a question on your test, and a lot of students got C wrong or got confused on how to set it up. So let's read the problem. The temperature one morning in Antarctica is negative 27 degrees. So we know it's quite cold there because it's all icy and snowy, so it has to be below 0. Over the course of the day, the temperature reaches a maximum of negative 16. Now, remember, negative 27 is less than negative 16. So that's actually risen. And the question asks us, how much has the temperature risen? So you can just count, so we're going from 27 down to negative 16. So you can go 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, and that gives me 11. Okay, now we could have worked this if you wanted to. That's the safest way to get that answer. So for 9a, just move that across. We had 11, okay, degrees Celsius. That was how much the temperature had risen. Okay, we don't have a negative in front of this because we're just simply saying it rose 11 degrees. So 9a was a bit tricky. Not tricky, just remember that if we're at negative 27 and the temperature went higher and it reached a temperature of 16 degrees Celsius, just go down by ones, 27, 26, 25, until you reach 16. The difference between, I guess the space between these two in this case was 11 degrees. So now with B, let's have a look and see what B asks us. Once it has reached its maximum, the temperature drops 14 degrees. What is the temperature now? Okay, so what was its maximum? It tells us in this question it was a maximum of negative 16 degrees Celsius. So I'll write that down. So we reached the top of minus 16 degrees Celsius, which is still very, very cold. Everything will still be frozen. And then it tells us so just say this will probably be at lunchtime or 1 o'clock, and it reached a high temperature of negative 16 degrees. It started to become dark again and nighttime again, and it started to drop. And it drops minus 14 degrees, okay, Celsius. So we can just write our question like this. So minus 16, minus 14, okay? And when we have a problem like this, minus 16, minus 14, because they're both negative, we can just add them. So I know that 16 plus 14 will give me 30, but of course it is negative 30, okay? And that's the temperature now once it's dropped from negative 16 degrees Celsius. And question C, now C was the one that confused quite a few students. The lowest temperature ever recorded in Antarctica was minus 89 degrees Celsius, and the warmest temperature was 15 degrees Celsius. What is the difference between these two? And we know when we hear that keyword difference, we are subtracting. Now remember, when we subtract, we always have to put our bigger number first, take away our small number. And if we do that, what's our bigger number, 15 or negative 89? 15 is larger. So I'm going to write, and I know difference means take away, so I'm going to write for C. I'll squeeze it down here. We have 15. The difference is take away, and my number that I'm subtracting is negative 89. And now a negative and a negative make a positive. So what is 15 plus 89? It is 104. Okay, now we don't put degrees Celsius. We're just saying, or you can if you want to, but we're just saying the difference in temperature is 104. Oh, yeah, actually, no, we can, 104 degrees Celsius. Okay, so just remember, problems like this, if you want to use a number line, you can, but if we're asking what's the difference, it's like saying what's the space between them. If we're at 15 degrees Celsius, on our number line, if I just clear the page, on our number line, we would have 15 degrees all the way in the positive end. Just say there's 0. And then negative 89 will be all the way down the other end because it's negative. And what's the difference? What's the gap between them? So a trick is all you have to do is add 89 and 15, and that will give you the difference. Our last question, we'll do a factor tree. And I'll pick a number. I don't know, let's pick 24. And if the question asks you, I'm not writing the question up, so you can just listen. Draw, it might say using a factor tree. So using a factor tree, express 24 in prime factor form. Express means show, and prime factor form, what's the key word in that? Prime. And prime factors. So if you see prime factor form, express it in prime factor form, it's saying show 24 with its prime factors. And every number has factors that are prime numbers. So what you do is you start with 24 on top, and a factor tree has branches. And what is something times something to give you 24? I know that 2 times 12 is 24 and 4 times 6 is 24. You pick whatever you want. I might just go, well, 2 times 12 is 24. Okay, I usually start with my small number first to make it neater. Now, 2 is a prime number. Okay, only 1 times 2 can give you 2 and no other numbers. So I stop there. So every branch stops at a prime number. 12 is a composite number because it has more than 1 in itself as factors. And I know that 2 times 6 gives me 12. I stop at 2 here because 2 is a prime number. But 6 isn't because I know that 2 times 3 is 6. Now check, is 2 a prime number? Yes. Is 3 a prime number? Well, 1 times 3 is 3 and nothing else can give me 3. So I have finished my factor tree. And now I'm going to circle all of my prime numbers that I have. I've got 2, 2, 3 2s, and a 3. Now, with these prime numbers, your next step is there's an invisible multiplication symbol all between these numbers. And we actually have 2 times 2 times 2 times 3. Now you must do a check. When you multiply all of the prime factors, it should give you the number you have on top, which is 24. Let's have a look. 2 times 2 is 4. 4 times 2 is 8. 8 times 3, yes, it's 24. So I have the correct prime numbers. And now we have to simplify this. And remember the question at the beginning? You have 1, 2, 3, 2. So I write my 2, and now the power changes. Because I know that 2 to the power of 3 is saying 2 times 2 times 2. Then write your times. It's always times in between because we can see the multiplication symbol. And I have a 3 there. I only have 1 3, and therefore that is my final answer. And if you put that into the calculator, 2 to the power of 3 times 3, it will give you 24. And this is expressing it in prime factor form.